In this video, we're going to examine the three classical states of matter. When we talk about the states of matter, we're talking about how we can kind of see it in life. And we're going to use water as our example. When we talk about water, you can think of water can be ice, water can be liquid, and water can be a vapor, can be a gas. You've encountered all three of these different states of matter within your everyday life. Water is an ice cubes. Water is a liquid, refreshing beverage we all drink. Water is a vapor. Could be took a really hot shower, nice and steamy, went into a sauna, had some tea. All of those contain water as a vapor. So when we're looking at our three different states, we can tell them apart by visually looking at them, but they also have definitions. So if something is a solid, it has a defined volume and a shape. If you think about your ice cube is not going to all of a sudden change its shape on you. It's not going to go from being a cube to all of a sudden being a round ball or a sphere. It's going to stay that cube. No matter what container you put it in, no matter what you do, as long as it stays ice, it's going to stay the same shape. Liquid, on the other hand, has a defined volume, but not a shape. Think about the water you just poured into a cup. Water will take that shape of the cup. But if you take water, you can't really compress it down and make it smaller. It's going to stay that same volume. I can't take the water in my cup and kind of push it down and make it tinier so I can carry more around. It's going to stay that same volume. Gas, on the other hand, does not have a defined volume or shape. So gas can be compressed. And you've encountered this before. If you've ever heard of anybody that's gone scuba diving, they can have compressed gas in their tanks. So that way they can carry more air down with them and more oxygen with them. Also, some public transportation runs on compressed natural gas. They took natural gas and compressed it so they can fit more gas per the volume. And one thing also, gas will take whatever shape of container you put it in. So if you blew up a balloon, the gas is going to take the shape of that balloon. If you blow up a regular looking balloon, it'll take its regular shape. There's my balloon. If you blew up a heart-shaped balloon, it's going to take up a heart shape. Or if you blew up a square balloon, it'll take the square shape. So gas will take whatever shape you use. Gas will take whatever shape container you put it in. Looking a little more closely at these three different states, we'll first start with solid. So when we look at solid, there's two different types of solids we can have. There's a crystalline solid and an amorphous solid. In a crystalline solid, the atoms are arranged in nice, pretty geometric patterns. And it's a repeating pattern, repeating shape over and over. Crystalline solids could be something like sodium chloride forms a nice, pretty crystal solid. Most ionic compounds will form nice crystalline solids if you let them cool slowly. Amorphous solids, on the other hand, do not have a nice, pretty shape. They have no regular pattern. So it's almost like you took a bunch of balls and you just threw them all together into a bag and zipped it up. It's not going to lay there nice and pretty. Or you can think of it if you have a bunch of popcorn in a bowl. It's just like all those popcorn pieces. They're kind of just arranged in there like really randomly. And amorphous solids tend to be usually your organic compounds. Plastics tend to be amorphous. So they don't really have a nice repeating pattern. Now looking at liquids, liquids have a fixed volume. And this is because the atoms and molecules are really close to each other. If we look at our water molecules and we zoom in, we can see that they're all right next to each other. There's not really any space. This is why you can't compress a volume. There's no space to compress. We can't take the atoms and smash them into each other's space. That'd be like taking two people and trying to smash them together into one person. It doesn't work. But a liquid shape is not defined. This is because They are close together, but the atoms can and the molecules can slide across each other. So they can slide and start moving. Nothing's holding them in a fixed place compared to each other. So since the atoms can move and slide, that's why the shape is not defined. So examples of liquids we have could be water, gas, alcohol. Mercury is an example of a liquid. All of those will have a fixed volume, but not a fixed shape. Finally, looking at gas. Gases are atoms or molecules that have been separated by a really large distance. And they tend to move freely of each other. So if you have a gas, you can see here with our helium atoms, there's a lot of empty space in between them. They're nowhere near each other. And because there's all this empty space, that's how you can take a gas and compress it down and make it smaller. So you can take a gas, compress it from the larger circle here, can make a smaller one. And now our atoms are a little bit closer together. They're still not completely touching each other like the liquid, but now they're a little bit closer together. I think I missed a couple there. But so this is how gases have their ability to be compressed. This is why gases are compressible. That's also why there's no fixed shape or volume. So example of gases, oxygen we breathe, helium that's in our balloons, carbon dioxide. All those are different examples of gases. So now we've seen our 3 classical states of matter. There are a couple other ones that are considered non-classical, and we'll see those during lecture time.